we have two charges on a number line. The charge here is -8 times 10 to the -6 coulombs. The charge here is a mystery. We want to know the sign and magnitude of Q2 so that there's no electric field at the origin. So we want to cancel it out there. So the electric field, the net electric field at the origin is going to be equal to the electric field due to 1 plus the electric field due to 2. Now the electric field at this point due to this charge is going to point that way because a small positive test charge placed at the origin would be attracted to this negative charge here, so it would go to the left. That means that the electric field due to Q2 has to point to the right so that these two vectors can cancel out, which means this charge also must be negative so that it would be attracted. A small positive test charge placed here would be attracted to this charge. So they're both going to be negative. Now let's add up their magnitudes of their field to figure out what this magnitude would have to be. So we have k q1 over r1 squared plus k q2 over r2 squared. Now which one of these is going to be negative? This one there. So the field due to q1 will be negative because this vector points to the left. And those added together will equal 0 because we want them to be 0 at the origin. So I'm going to say kq1 over r1 squared equals kq2 over r2 squared. Now we're solving this for q2. So I'm going to multiply both sides by r2 squared. And then I'm going to divide both sides by k. And look, the k cancels out. And then we can just plug in some values. So we have q2 equals r2, which is 5 squared, times q1, which is -8, but we don't need that negative sign right now. This is just the absolute value of the charge. Okay, there's the charge divided by r1 squared. So that is 4. It's 4 away from the origin squared. So when you do this math in your calculator, you should get -12.5 microcoulombs. The magnitude of the charge will be 12.5 times 10 to the -6, and that charge must be negative. So that's why the answer is A.